So we want to talk a little bit about precision in measurement. Precision is basically how good your measurement is, okay? When we're measuring stuff out in labs, sometimes it's really important to be super, super precise, okay? So for example, if I'm measuring out acid for a titration, titrations have to be like exactly perfect. Like 1 drop is the difference between the answer and past the answer. So if we need something to be super precise, I'm going to use a burette. Okay? But for most of our everyday things, we don't need to be that precise, but we do want to be fairly precise. So our sort of middle of the road precision is a graduated cylinder. That is precise. Things we would never use to measure would be things like beakers. Beakers are really only for holding stuff. They have lines on them so you can kind of estimate how much liquid you have in a beaker, but really beakers are designed for holding and not measuring because they're not very precise. Erlenmeyer flasks, again, has lines on it, but not very many, and so it's more of an estimate of your volume. So really not great. Not great. All right? So what makes something more precise? All right? It's the number of lines. In general, the more lines, the more precise. Oops. There we go. So that's why a graduated cylinder, so if you look at my graduated cylinder, I know it's kind of hard to see because it's clear, but here, let me put my hand behind it. There we go. So we've got a line at the 40, we've got a line at the 50, but then we've got little tick marks between 40 and 50. So this would be 41, 42, 43, 44, 45, 46, 47, 48, 49. So we actually have lines to the ones place on a graduated cylinder, whereas on a beaker, we only have lines to the tens or sometimes even the hundreds place. So there are much fewer lines on a beaker than there is on a graduated cylinder. So a graduated cylinder has more lines. It's definitely going to be more precise. A thermometer, for example, used for measuring temperature. So they know that you're using this to take a measurement. So again, we've got the 20 and the 30, but between the 20 and the 30, we've got the little tick marks. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And so we're able to get all the way to the ones place with this, as opposed to the tens or the hundreds place. So more lines, more precise. So when we're reading one of our tools, and I'm going to use some pictures of them just because it's a little easier. When we're using pictures, we want to make sure that we are reading to the level of precision that the tool provides. So if you look at this here, we've got a graduated cylinder section. We have the 50, we have the 60, but then we have our lines in between, so that's our ones place. All right, so we can see that the line, or the liquid line, is right on the 56 line. So most people would write this volume as 56 milliliters. That would be wrong. Your volume is always going to be the most lines you can measure, and then one more digit that you're going to estimate. So since this is right on the line, I would actually call this 56.0. This 0.0 tells me that it's right on the 56 line. It's not a little bit above it, kind of stuck in the middle between 56 and 57. It's right on that line. That's what putting that little 0 is. And then, of course, I always want to put my unit, milliliters. Okay, so now let's look at this next one. This one here is really different. Okay, you'll notice that we still have all of our pretty lines, but this time our volume line is between two lines. So it's 4, because we're past the 4, it's above the 4, so we know it's 4 point, and then we count our lines, 1, 2, 3. We're at least to the 3, but not quite to the 4, so I'm going to write down the 3, and now I'm going to estimate. Now, it's almost halfway. It's almost right in the middle, but I think it's a little lower than halfway. So I'm going to scale of 1 to 10 this. Halfway would be 5. Since I think it's a little lower than halfway between the two lines, I'm going to call this 4.34. Now, someone else might call it 4.35. Someone else might call it 4.33. All of those would be acceptable. This final digit is an estimate. Okay? It's an estimated digit. All right, let's do one more of those. So here's our water line. It's above the 20, so I'm going to put 20. And then I'm going to count 21, 22, 23. It's between 23 and 24. So I'm going to put 23 because we're not quite to 24. That's where my decimal would go. And now I'm going to estimate how far between those two lines is this. And now this one looks about halfway, but this time it seems a little higher than halfway. So I would maybe go as high as 7 on this one. Someone else might say 8. Someone else might say 6. That's okay, because remember, this last digit is estimated. These two digits are certain. We know that it's past 20. We know that it's past the 3 mark. So those are certain digits. The last one is estimated. So any measurement you ever take is always going to be your certain digits plus one estimated final digit. All right, let's do a couple examples with a thermometer. So here we have our thermometer, and see how it's kind of a bubble? We want to read from the very, very tip top of the bubble. So we know that it's at least 60, but not quite 70. So we're going to put the 6 for 60, and then we're going to count 1, 2, 3, 4, 5, 6, 7. It's past the 7, but it doesn't look like it's quite to the 8. So I'm going to call this, oops, nope, sorry guys, 67. Now it really is almost to the 8. We're really close there. So I'm going to estimate that last digit as a 9. So I'm going to call this 67.9 degrees Celsius. On this thermometer, we're in the negatives. So remember, these numbers are kind of going backwards. So this is 0, this is -5, so this is -1, -2, -3, -4, and -5. So we are at least at -2, but not quite to -3. So I'm going to put this as -2 point. Now I'm going to estimate, and be careful because remember, this is going kind of weird. It's backwards. So 2 is here, 3 is there. So we're kind of almost to the 3, but not quite. I would call that 2.7, -2.7. Some people might call it -2.8. Some people might even call it -2.9. Again, that last digit is estimated. All right? So you're going to have a few of these that you're going to want to practice.